morning, good afternoon, good evening, wherever I may be watching this from. This is Cornelius Luvinda. And then we have another question here. So it's a continuation from the previous video. We are continuing here. So this is additional mathematics vectors, collinear points. Given that OP is equal to vector A plus vector B, OQ is equal to K of vector A, and OR is equal to 7 of vector A minus 2 of vector B, we find the value of K if Q lies on PR. So this last statement, Q lies on PR, means that P, Q, and R are collinear points. They lie along the same straight line. Therefore, you can just proceed with the answering. First of all, let's write what we know. OP is equal to vector A plus vector B, and then OQ is equal to K of vector A, OR is equal to 7 of vector A minus 2 of vector B, like that. So you have those three vectors. Now, like I said in the other video, when we are finding the value of mu, here we have K. So we need to think of two resultant vectors, alright? Using the points P, Q, and R. P, Q, and R. We think of 2 points that when you answer in your equation, or in your vector rather, there will be K there. So we can't use these because you can't use this and then you compare with this here. This does not have K, so you cannot compare things without K. What do? So let's do this. Let's get P and Q. This is actually a point. Because it's a position vector, it means it starts from the origin. So OP is a point. We'll say P, Q is equal to PO plus OQ. PO is minus vector A minus vector B plus K of vector A. Then if we group like them together, K of vector A minus vector A minus vector B. Then if we factor out the vector A there, K minus 1 of vector A minus B. This is our P, Q. So have you seen this? This is a new vector that we have made. Just by manipulating these vectors, the position vectors here, we have this vector here that has K. The K is very important. So P, Q is equal to K minus 1 of vector A minus vector B, like that. Then to proceed, again we think of another vector that can have K. Another vector that can have K is, we have this one and this one. So we have this one and that one, this one and this one. And that one can simply be QR or RQ. Whichever way you still get the same answer. So QR is equal to QO, sorry for that, QO plus OR. QO is minus K of vector A, OR is plus 7 of vector A minus 2 of vector B, like that. Then we substitute, we group like terms together, the ones having vector K. So let's do this. 7 of vector A minus K of vector A minus 2 of vector B. And then we factor out the vector A. This will be 7 minus K of vector A minus 2 of vector B. This is Q R. So we have created another vector QR. QR is equal to 7 minus k of vector A minus 2 of vector B. Now this QR is very, very important. Why? Because if you compare this QR, alright, let me erase the QR anyways, since I've already written it down. If you compare, so follow me very well here, if you compare this QR here to this PQ, you can see that quite alright we have something in the brackets with K, and then there is vector A, something in the brackets with K, then there is vector A. So 7 minus K, vector A, K minus 1, vector A. Now here there is vector B outside, minus vector B. And then here there is a 2. So minus 2 of vector B. Alright. We're trying to find the value of vector A here. What we do is we simply need to equate this, alright, this with vector, this in brackets, that is with vector A, is equal to this in brackets, that is with vector A. Now we cannot simply equate because of these two. This 2 is trying to show us that they were multiplying the whole of this by a certain number. Now we can't know that number since we don't know K here. You see what I mean? So it means this 2, we need to multiply it on this vector here. Alright, if that didn't make sense, follow me with my answering. So this means I'm saying this part, the QR with vector A, so 7 minus K, I'm just going to get that 7 minus K. Then I'll say is equal to K minus 1, like that. So I've just equated what is in this bracket to what is in that bracket. Now why I have put brackets here and no brackets there is because of this 2 here. This one had a 2. Now this one does not have a 2. So we need to look for that balance. We are going to put a 2 right there because it's signifying this was multiplied by a certain scalar. Scalar is simply a number. Then we just answer normally 7 minus K. We keep everything the same. 2K minus 2. We group like them together. 7 plus 2 is equal to 2K plus K. Alright. So 7 plus 2 is 9. 2K plus K is 3K. You divide both sides by the 3. Divide by 3. 3 can go into self 1. 3 can go into self 1. 3 can go into self 1 into 9, 3. Therefore, K is equal to 3. And that is your final answer. Thank you so much for watching this video and staying until the end. This has been Cornelius Binda with another video, and bye bye.